Good afternoon, Ethan. I have a couple questions for you today. First, how dangerous is the smoke to occupants and firefighters when a home structure and its contents burn?
Thank you for the question, Felix. In addition to heat, home fires produce smoke, which is a combination of airborne solid particles and gases. Smoke from a fire is a significant threat to human health and safety. Here are a few key facts about smoke toxicity. First, most fire victims don't die from flame exposure, but from the inhalation of smoke, carbon monoxide, and other toxic gases. A second point is that there are many diverse materials used to manufacture a home structure, and its contents will result in the release of thousands of even more diverse chemicals and toxic gases during a fire. Finally, firefighters have an additional concern, since they can be repeatedly exposed to smoke and soot during and even after a fire. Some toxic residues can attach to the protective gear and can be absorbed through the skin during handling of personal protective equipment.
Thank you, Ethan. Can you also discuss how the presence of flame retardants impact the overall smoke toxicity during the course of a fire?
Of course! You may recall that the purpose of flame retardants is to prevent ignition of an item in the first place. So, it is important to recognize that without ignition, there is no fire, almost no smoke, and toxicity concerns are minimized or eliminated. But even if a fire does start, studies show that flame retardants can slow flame spread and decrease a fire's intensity. This means that large amounts of toxic smoke can be prevented through the use of flame retardant materials. Without intervention, a fire can grow and flashover may occur. This happens when a fire's temperature becomes so high that all combustibles in a room ignite. At this point, the fire becomes too large for flame retardants to be effective in most applications. In a fully evolved fire, some flame retardants function to reduce the toxic smoke generation. Other flame retardants, although they function very effectively during the early fire stages, may increase the smoke content. And importantly, studies have shown that many flame retardants have a minimal or negligible effect on smoke generation. In sum, each of the dozens of flame retardants in common commercial use will degrade differently in a fire. Further studies are ongoing on this complex topic. Also, researchers continue to study health effects to firefighters from exposure to thousands of decomposition products that form from a fire, including flame retardants. These studies involve possible exposure pathways and absorption risks to firefighters before, during, and after suppressing structure fires. But remember that in residential homes, most materials are not flame retardant. Flame retardants are only used in select applications where fire safety experts have determined a greater fire risk. This means that when a home and its tons of contents burn, flame retardants represent only a small percentage of the total weight of all available combustible materials, and therefore, during a fire, can only degrade to form small percentages of the existing smoke. So, to sum it up, in a real-world fire, there is no such thing as safe smoke, and toxic smoke will be formed with or without the presence of flame retardants. Flame retardants neither universally increase nor decrease a home fire's overall toxicity.
Thank you, Ethan and Felix, for discussing this complex topic. For further information,